All right, let's look at part C. We have x equals y plus 2 and x equals y squared. And these are two functions provided to us, and we're looking at the region between these two. And obviously, one thing that you should pay attention is that these functions are given in terms of y. So one is like x equals f of y, that is y plus 2. And the other one is x equals g of y, which is y squared. So the formulas that we worked through earlier will not work anymore because let me just show you what they are. So the integrals were written in terms of dx. Since now we are using the y formulation, so we should probably consider the y formulation of the same problem. So in other words, first we're going to graph f of y and g of y, which is y plus 2 and y squared. Please go ahead and graph these two functions and see what they look like first, and I'll tell you how the modification occurs for the integrals, and we're going to write them in terms of dy, okay? So you can pause the video at this moment, just graph these two functions and see if there's any intersection going on here, okay? So and I have the visual here. So these two graphs, one is a parabola, the other one is a line. So the red one is a line, the blue one is the curve. So they do intersect at 2 points, okay? And in fact, the region that's mentioned in the problem is the yellow region, and we're supposed to find the center of mass of the planar lamina, having that kind of like region or surface, okay? So one task is obviously to find, in fact this is the first task, is to find the intersection points, even though we can observe those from the graph, but probably you won't be able to see it from your calculator output. So I'm going to set the x values equal to solve y squared equals y plus 2, okay? So I'm going to subtract y plus 2 from both sides. Y squared minus y minus 2 equals 0. Okay? You can go ahead and use your quadratic formula to find the zeros here, but I'm going to do my own way to factor this quadratic. So first of all, I factor y squared as like y and y. And I factored this in a way that the product of minus 2 is going to be minus 2. So I'm going to find two numbers whose product is going to be minus 2 and whose sum is going to be minus 1. There's a hypothetical minus 1 here in front of y. So the sum of those numbers should be 1, in fact negative 1. Okay? So give me two numbers whose product is negative 2 and the sum is negative 1. And I can tell you that these numbers are negative 2 and 1. Okay, negative 2 and 1. So this tells me exactly how the factorization of the quadratic works. So that's y minus 2, y plus 1 equals 0. Okay? This tells me that the y coordinate of the intersection is 2. So, and the other intersection point comes with the y coordinate negative 1. Okay? You can go ahead and find the corresponding x values by using maybe this function x equals y squared. So if y equals if y equals 2, then x equals 4. That's exactly the x entry of that point. Okay, and also for y equals negative 1. Negative 1 squared is 1. So x coordinate of the intersection is 1. Okay, do we need those? No, because we're going to set this problem up with respect to the y variable. So we're not really thinking about the x business here, because in the formulation we have the top function and the bottom function. We don't have the top function and bottom function with respect to x here, but with respect to y. So in that regard, I'm just going to clean this part up a little bit, and I want to say that we're going to look at this region with respect to y-axis. So when I say top, I mean top in this direction, in x direction. So what that means is this red line bounding the top part of the region is going to be what I'm calling top, and that's going to be my f. The function corresponding to that is going to be my f. And the bottom portion of the region is the blue. I'm going to call that to be the bottom. and I'm going to represent that by g. Okay, f and g, top and the bottom, and then the y limits for the integration would be in between, as you see, -1 and 2. So the y values in this region, in the yellow region, are changing from -1 to 2. All right. So why don't we go ahead and then rewrite these formulas for y, okay? So essentially we're going to have f of y, g of y instead of f of x, g of x. And for the top and the bottom limits would be, lower and upper limits would be -1 and 2. And this dx is not going to exist anymore, right? This is going to be all dy, okay? So these guys are going to be y, and same as here, y and y and y, okay? And then here we have y, y, and y, okay? And this time a and b would be the lower and upper limits of the y values in the region, okay? So in that regard, this a is going to be -1, this a is going to be 2, -1, 2, right? -1 and 2. And f of y, as I said, is going to be the line, and g of y is going to be just y squared, which is the curve. All right, so let me just move everything down to the next slide, and I'll just clean this up, and we will try evaluating these integrals. All right, so I copied everything down here, and now we can go ahead and put the f and g back into the formulation. So let me just clean this up first. So this is f plus g over 2, so it's going to be y plus 2 plus y squared over 2, and f minus g is going to be y plus 2 minus y squared, okay? And same here, right, f minus g, right? Y plus 2 minus y squared dy, and same as in little m, right? So we're going to do, we're going to calculate these integrals, okay? All right, first of all, I'm going to rewrite m sub y. And I'm going to skip certain steps here because this video is too long, and will be too long, in fact. So please convince yourself you can pause any time during the video, okay? So this is going to be y plus 2 quantity squared, y plus 2 quantity squared minus y to the 4th divided by 2 dy, okay? And m sub x is going to be rho, integral from -1 to 2, 2y plus y squared minus plus y squared minus y cubed dy. And m is already in the simplest form, so I don't need to modify that. And now this is your task. Please pause the video and find these integrals by integrating them one by one. And you can use the power rule for integration because these are not hard integrals to work with. Okay, so let's start with m. So m, little m, should be 9 rho over 2. Okay, m sub y should be 36 rho over 5, and keep those with the exact values. Don't round them off. Okay, please get those like as fractions times rho, because in each case rho is going to be carried forward. And m sub x is going to be, let's see, m sub y is that. M sub x is going to be 9 rho over 4. Okay. And now we can go ahead and write x bar as m sub y over little m, and that's going to be 8 over 5 after we simplify, and y bar is going to be m sub x over m, and that is going to be just 1/2. Okay, it's just going to be 1/2. So this tells you the x and y coordinates of the center of mass. It's 8/5 and 1/2. So we can go ahead and write that down. Let me just clean this up a little bit to save some space here for us. Okay. So regardless of the density of the region, so this yellow region could be made out of steel or cotton or aluminum, doesn't matter. So this center of mass located right here is going to come with the coordinates 8/5 and 1/2. All right. Again, I skipped some calculations here. I'm sorry for that, but this video is getting extremely longer. And please do these integral calculations here to find those definite integrals for little m, capital M sub y, and capital M sub x. Okay, and convince yourself that the center of mass is located at 8/5 and 1/2. All right. I think we ended all parts of this question. Thanks for watching. I'll see you in another video. And don't forget to send your questions, comments, or suggestions on my way, okay? Bye.